Okay, welcome back. Unit 1, Lesson 1, Example 3. Here we have Neil, and they're riding a Ferris wheel that has a diameter of 6 meters. The axle of the Ferris wheel is 4 meters above the ground, and the Ferris wheel takes 90 seconds to complete one rotation. And we know that Neil rides for 10 rotations. So what are the domain and range of the function that models Neil's height above the ground in terms of time while he rides the Ferris wheel? All right, so the first thing that we're going to do is we're going to make a diagram. Oops. And we know a Ferris wheel, circular, so let's draw a circle. And they've stated that the diameter of the Ferris wheel is 6 meters. So we know from one end to the other is 6 meters. Actually, I'll put that somewhere else in a bit. And we know the axle of the Ferris wheel. So the axle is its center point. And we know that if this is the height and this is 0, the Ferris wheel's axle is 4 meters above the ground. So this has to be 4 meters above the ground. And since we know the diameter is 6, we know the radius is going to be 3. So we know that this point here is going to be 7 because 4 plus 3 is 7. And then we know that this point here is going to be 1. So here we have 1, 4, and 7. Those are my 3 main points. So let's figure out domain and range. Well, range has to do with my height, which is here, and time is here. And what are the possible values of height? Can Neil be infinitely above the ground? No, probably not. There's a maximum limit of 7 meters above the ground because that's the highest the Ferris wheel goes. And then the lowest the Ferris wheel goes is 1. So the range is very easy in this case. So in this case, I'm going to write h of t because that's my function notation. And we know that all the y values of h of t belongs to all the real numbers such that, and now since there is a limit, this function does not go, this relation does not go all the way up and all the way down. It goes down all the way up to 1. And we know that the function is bigger than 1, so it's greater than equal to 1. It can equal 1. And we know that it has to be smaller or equal to 7. That is the upper limit. So range is between 1 and 7. Oh, forgot to put brackets. H of t. What about domain? Well, we know that time starts at 0. So whenever we start recording Neil's height, we know t is going to be 0. So we know that time is going to be similarly belonging to all the real numbers, such that 0 So what's the upper limit though? How long is Neil going to be on this ride for? Well, we know that it takes 90 seconds to make one complete rotation, and Neil was on it for 10 rotations. So 90 times 10 is 900 seconds. So depending on what unit they want, in this case, let's say they want seconds, we can just write the domain is between 0 and 900, and it's equal to 0 and 900 because there's no limitation. There's no reason why time can't be 0 seconds or 900 seconds. Okay, hopefully that helps. Here are some summary items. So need to know function notation f of x is used to represent the values of the dependent variable in a function. Y is equal to f of x. It's kind of something you've learned in grade 11. You can use the vertical line test to determine whether it's a function or not. And when I say it, I mean a relation. So in this case, the first graph here is a function. The second graph is not a function because the vertical line intersects this relation at more than one point. The domain and range of a function depend on the type of function. And depending on real life examples, sometimes you may have to limit the variables. such as in the earlier example, there cannot be a negative dimension or negative time.